gate exercises on Boolean algebra using Arduino. In this lecture, we select some questions related to the Boolean algebra from the previous gate examination and we solve it using Arduino. Problem 1. The inputs to a digital circuit shown in the following are the external signals A, D and C. The 5-volt power supply as logic 1 and the ground as logic 0 are available. The output of the circuit is x is equals to a bar dot b plus a dot b dot c whole bar. Write down its output function in terms of canonical, sum of products and product of sums forms. Theoretical solution for the problem 1. So, let us write a truth table for the given problem. A, B, C are the inputs and x is the output. The x output is shown by that Boolean function given in the numerical. So, canonical SOP. In canonical SOP, 0 is taken as a not of the variable and 1 is considered as the actual value of the variable. So, here what we do is, we check wherever 1 is available in the truth table for x, and by using that we form the sum of products. The sum of products for this x is xSOP is equals to a bar dot b bar dot c bar plus a bar dot b dot c bar plus a bar dot b dot c. Canonical POS. In canonical POS, 1 is considered as the negation of the variable and the actual value is considered as 0. So, in truth table, we select the output which is 0 and by using that we form the product of sums. In product of sums, XPOS is equals to A plus B plus C bar into A bar plus B plus C into A bar plus B plus C bar into A bar plus B bar plus C into A bar plus B bar plus C bar. Arduino based solution. Initially, we will take the Boolean expressions in our numerical, and for those Boolean expressions, we write the C code. By doing this, we will understand the number of inputs and number of outputs. By understanding the inputs and outputs, we can understand what are the requirements of our hardware. So, here we have 3 outputs. First is the quotient output x and xSOP and xPOS, which has to be compared with x. So, the hardware setup is here. Here, actually this is a general hardware setup for gate based questions solving using Arduino. Here, first LED refers to the question and remaining 4 related to the option. It's a general hardware setup. But for us, now we require only 3 LEDs. 3 output pins. Those are sufficient for us. So, X, XSOP, XPOS are related to the first 3 LEDs as shown in the image. So, we observe the output from these 3 LEDs only in our hardware setup. Here is our Arduino code. Here X, XSOP, XPOS are the output variables. A, B, C are the input variables. For output variables, we are assigning the pins 7, 8 and 9. So, in the void setup, we assigned 7, 8, 9 as output pins, and in void loop A, B, C are initialized by giving 0. A is equals to 0, B is equals to 0 and C is equals to 0. Here X, XSOP, XPOS equations are written in C by analyzing the Boolean expressions. By using digital write command, we write the outputs which are computed to the pin number 9, 8 and 7 with X, XSOP, XPOS respectively. So this is the code. You can dump this code and observe the demonstration. Let's see the demonstration. So now let's give the inputs A is equals to 0, B is equals to 0 and C is equals to 0 and dump the code. You can see these three LEDs are glowing. By this we can say XSOP and XPOS are correct. But let's go for the more options. So now let's give A is equals to 0, B is equals to 0 and C is equals to 1. You can see that these three LEDs are not glowing. Now give A is equals to 0, B is equals to 1 and C is equals to 0. And you can see these three LEDs are glowing. So by this we can say it is satisfying the conditions. But let's go for the final option. A is equals to 0, B is equals to 1 and C is equals to 1 and dump the code. Now you can see these three are glowing. So by this we can say that those three equations are satisfying. Our answers are correct. Problem 2. A function of Boolean variables x, y and z is expressed in terms of the mean terms as f x, y, z summation 1, 2, 5, 6, 7. Which one of the product of sums given below is equal to the function f of x, y, z? So here are the options also given. This numerical is as similar as the problem 1. So this you can try by yourself and with the same hardware setup. In this we use all the 5 LEDs. So problem 3, the Boolean expression x bar dot y dot z bar plus x bar dot y bar dot z plus x dot y dot z bar plus x dot y bar dot z plus x dot y dot z can be simplified to be option A, x dot z bar plus x bar dot z plus y dot z, option B, x dot z plus y bar dot z plus y dot z bar, option C, x bar dot y plus y dot z plus x dot z, option D, x bar x dot y whole bar plus y dot z bar plus x bar dot z. So for this we directly go for the Arduino based solution. So you can see in this slide here in the left side we have the Boolean expressions including the options, and right side we have the syntax for the Boolean expressions. By this we can understand we require 5 output pins and 3 input variables. Totally we require 5 plus 3, 8 variables and 5 output pins. So let's see the hardware setup. Here is our hardware setup. We have 5 LEDs connected to the 5 digital pins of Arduino. First LED is F, which is the output of the question, and remaining 4 LEDs are A, B, C, D respectively, and these are for the options. If the question LED glows, any one of the option LEDs also glow, then we say that this question has some relation with this option, particular option. And at the same time, when it off, this also should off. It means to say that whatever the conditions the output LED is satisfying, the option LEDs also should satisfy those conditions. If it is satisfying the conditions, then we say that that particular option is our answer. So let's see the code. So here is the Arduino code. As I have said, we have 8 variables and 5 variables are output variables. So for those output variables, we assign some pins, and in the void setup, we assign those pin numbers as output pins. Here we are selecting 5, 6, 7, 8, 9 as our output pins. In void loop, we will give x, y, z our input variables, and as well as computational logic equations also. These equations are obtained by observing the Boolean expressions. We change the values of x, y, z when we are dumping the code for verifying the options. Let's see the hardware demonstration. Let us give the inputs x is equals to 0, y is equals to 0 and z is equals to 0 and dump the code. You can see F is not glowing, but D is glowing. So by this we can say D is not our answer. Among A, B, C, anyone might be our answer. So let's give the inputs x is equals to 0, y is equals to 0 and z is equals to 1 and dump the code. You can see A and B are glowing and C is not glowing and F is glowing. It means C is not our answer. Among A and B, any one might be our answer. So let's go for the another condition and get the final answer. Let's give the inputs x is equals to 0, y is equals to 1 and z is equals to 0 and dump the code. You can see F is glowing, but A is not glowing and C is glowing. It means our answer is C. Whatever the conditions F is satisfying, all the conditions C is satisfying. So by this we can conclude C is our answer. Problem 4. If the functions w, x, y and z are as follows. W is equals to r plus p bar dot q plus r bar dot s. X is equals to p dot q dot r bar dot s bar plus p bar dot q bar dot r bar dot s bar plus p dot q bar dot r bar dot s bar. So y is equals to r dot s plus parenthesis negation of p dot r plus p dot q bar plus p bar dot q bar, and z is equals to r plus s plus negation of p dot q plus p bar dot q bar dot r bar plus p dot q bar dot s. Options: w is equals to z, x is equals to z bar. B. W is equals to z, x is equals to y. C. W is equals to y. D. W is equals to y is equals to z bar. We have to check which of the options are right. I mean, the conditions in the options are right. So here are the Boolean expressions and their C syntaxes. And this is the hardware setup for the problem 4. And W is corresponds to first LED, X is corresponds to second LED, Y is corresponds to third LED, and Z is corresponds to the last LED. So here is the Arduino code. We have 8 variables. Among them 4 are output variables and 4 are input variables. So we are need of 4 output pins, and they are 6, 7, 8, 9. In void loop we have input variables P, Q, R, S. We will be changing it as usually and dumping the code. And here is the syntax for W, X, Y, Z. And the computational output will be fed to LED with the help of digital write command given to the particular pin number. So let's dump the code and verify the output by hardware demo. Let's give the inputs P is equals to 0, Q is equals to 0, R is equals to 0 and dump the code. Now you can see LED related to the X is glowing, but W, Y and Z are not glowing. So it means we have to verify the conditions present in the options. So option A, W is equals to Z. Yeah, it is satisfying. X is equals to Z bar. X is glowing but Z is not glowing, so it's satisfying. So option A is satisfied. Option B, W is equals to Z, satisfied. X is equals to Y, no, it's not satisfied. So option B is not satisfied. Option C, W is equals to Y, yeah, it is satisfying. Option D, W is equals to Y is equals to Z bar, it is not satisfying. So among A and C, any one might be our answer. So let's give the inputs. P is equals to 0, Q is equals to 0, R is equals to 1, R is equals to 0 and S is equals to 1 and dump the code. You can see W is glowing, X is not glowing, Y is not glowing and Z is glowing. So option A, W is equals to Z, yes, it's satisfied. X is equals to Z bar, yes, it's satisfied. Now option C, W is equals to Y, no, it didn't satisfy. So by this we can say option A is our correct option. So the condition present in option A is satisfied.